Make in India policy is accelerating foreign direct investment. Manufacturing has received a boost and companies are gearing up to establish efficient and reliable supply chains. From a production perspective, it combines the digitalization and smart machines concept emerging from Industry 4.0 and smart manufacturing. Samarth Udyog is India's response to the fourth industry revolution. This journey is not one just about technology. It's also about changing the way we work, changing the way we think. What is unique to India is our ecosystem, which comprises a large number of small and medium enterprises.
Manufacturing is also a national priority, and it comes down to creating opportunities for SMEs to actually respond to this need. They need to be globally competitive.
The Indian ecosystem actually makes a very hard entrepreneur out of SME. So if a SME has the information to its market, the market demand, the logistic chain, the raw material chain, then I think Industry 4.0 actually comes to the aid of SME.
One is improvement in the means of manufacture. Second is the harnessing of the power of data which emanates from the manufacturing industry.
Getting small and medium enterprises is both exciting, but it's very daunting. Many of them are still the stage of pre-automation. We've factored in our journey the very process of bringing them in, taking them up the curve right up to Lean Six Sigma. Our first attempt would be to set up a small lab in which we will get the SMEs to come and see by example simple production processes, engage with them on what they've actually been doing in their current automation, and then slowly get them to see that the integration of IT and OT is not such a big situation.
We implemented this e-factory concept first in our manufacturing facilities in Japan and China. Our e-factory solutions are set to benefit Indian manufacturers to produce high-quality products at high speed to cater domestic needs as well as overseas market.
Smart manufacturing is basically a basket of technologies that starts from the IoT, connectivity, cyber physical system, augmented reality. So the role is basically to demystify the technology in the forefront, understand the technology as a teacher, and then the role is to pass on this knowledge to the people.
In the next 2 years, you will see hundreds of companies doing their R&D activities out of the IIT campuses, and that is where these industries will work closely with our faculty and students, work in a multidisciplinary kind of a fashion.
The automation industry also has a great opportunity to build upon its infrastructure, and I mean specifically with regard to the system integrator community. Not all of them have a national footprint. It's not easy for customers to find where they operate, what kind of uniqueness they bring in terms of their solutions. So as AIA, our job will be to bring them on board at least one platform.
We want to keep in mind where the Indian industry is going to be 10 years from now and prepare our students to meet those kind of challenges, to propel the Indian industries to the world stage.
Technology has a very crucial role to play in this. I think technology is that X factor which can bring about the transformation.
In my opinion, by and large, automotive and pharmaceutical are two important verticals that will benefit with Samarth Udyog.
Right place to start from is what is it that I want to do with my business? Where is it that I want to take my manufacturing operations to?
We have the capacity to be the leaders, and we should now take a charge.
Hello everyone. We welcome you to another masterclass on overview of machine learning in manufacturing, hosted by IITD-AIA Foundation for Smart Manufacturing, headed by Professor Sunil Jha. In this masterclass, you will discover the value that can be derived from the implementation, including production and post-production, and gain an understanding of how the technology is applied for predictive maintenance and predictive quality analytics. We will try our best to make this session as interactive as we can. We request you to please raise your questions in the question and answer section, and only relevant questions will be answered at the end of the webinar. I now request Mr. Anup Padwa, Director, Automation Industry Association, to please take over and for further proceedings.
Thank you, Naman. Good to see so many people coming back to this masterclass series. I can recognize many from the names of the participants. And also I noticed that there are several new aspirants to learning. So welcome once again to this fourth topic of the masterclass series, the overview of machine learning in manufacturing. As Naman has already said, we will be covering the most sought after questions which people have in their mind, and Professor Jha will address all of them in today's session. Just a little background about today's session and what we might want to do later. This is just the starting of the journey, and towards the end, Dr. Jha will also let you in our learning portal. He will also let you know what are the other programs that follow, including a follow-up program on the same topic. We are today assembled as a new generation from different aspects of engineering or science, and we are trying to create a new competency in India for the Atmanirbhar Bharat. This new competency will be a blend of mechanical engineering, data science, and many other aspects which go into the new world of smart manufacturing. Who else but can do this better than Dr. Sunil Jha? And that will be very clear when I just introduce his profile. Professor Sunil Jha has a PhD in manufacturing science from Kanpur IIT, and he has been in the teaching and research for over a decade. His areas of specialization are computer-aided manufacturing, computer-aided design, industrial automation, and digitization of mechanical components and tooling development. He comes with a background of working in an industry. He was with Tata Motors before he joined IIT Delhi in the teaching domain. And in his current capacity as director of IIT Delhi-AIA Foundation for Smart Manufacturing, Professor Jha is very closely working with manufacturing industry as well as with academia outside IIT, as well as many other government institutions which are trying to join in this collective journey for smart manufacturing. And very nobly and very, I would say with a great heart, he is sharing the new technologies, preparing everybody for the next industrial revolution. Dr. Jha also has a lot of other notable successes, particularly his development of the unconventional super finishing process. And he has filed 6 patents so far. Few of them have been successfully commercialized. A great teacher who loves to master the topic, simplify it, and then serve you in a nice story-like fashion. Today's program is going to be very interesting, I can assure you. Please enjoy the session, and please post your questions in the Q&A box. If you have any feedback or comments on the logistics or general questions, put them in the chat box. our backend team will attend to that, and the other announcements will be made at the appropriate time during the session by Professor Jha himself. Over to you, Dr. Jha. The session is yours.
So very good afternoon and welcome to this series of masterclass on smart manufacturing technologies. That I appreciate those who are participating in these series from last few webinars, and this is the additional webinar on a new technology which is really very fascinating and interesting, and you see a lot of terminologies related to machine learning are in limelight these days. So we are trying to find out many application of machine learning in various domains, and certainly manufacturing can also be the one of the field where the machine learning find a lot of opportunities and application into it. So I think that's a great opportunity to share my thoughts and learning with all of you in today's webinar. So let's start the webinar part. So I will again quickly brief about the foundation who is organizing these webinars. I am part of this foundation itself, which is a common engineering facility center at IIT Delhi under the mission of Samarth Udyog of Department of Heavy Industry, Government of India. So this was our masterclass series learning path, and as you have seen that we are right now conducting the awareness sessions, which are 2-hour live sessions connected with the e-learning on our platform, and we have already completed the first 3 webinars in this series, and so today we are having this overview of machine learning in manufacturing. And post this awareness session, now it's a turn to go towards the next level of learning, where we will be having more extensive handholding and workshops and sessions where you will be playing with these technologies and implementing yourself. So with this, we will be completing the basic awareness sessions, and some of these sessions will be repeated at the appropriate time that will be announced. But now we are looking forward to take up the learning series in this masterclass. And post that, we will certainly move towards the expert series, where we will be making you more expert on these technologies. So you will be ready to deploy some of these technologies in the field also. As those who are attending, those who are new, I'm just quickly briefing about the approach that we are adopting right now. We are having these live sessions, then we will also be connecting the attendees on the e-learning platform. So now it is open for self-registration, and then you will be able to enroll yourself into the selected courses. We'll also be conducting some of the live demonstration of these technologies while in the webinar, as well as we will be continuing the same in the learning as well as the expert sessions. We'll also be looking forward for the hands-on labs. Certainly in the awareness one, we are not conducting these hands-on labs. These are more designed to be learned during the learning phase of these technologies. So we have already prepared all this hardware and the connectivity through that you can access these kits remotely and conduct some of those experiments. We'll also be planning to have the course project when you go for the learning, and certainly the quizzes are the integral part of our webinars. Through that, we will be able to understand the level, and then we will be discussing the technologies accordingly. So this is our e-learning platform, where you will be already registering. Some of you have already registered, and those who are not registered, they can quickly go through the registration process. It is open for all, so they can go with this, create a new account. They can put their email ID in the username, and they can fill the rest of the details to get registered onto this website. So registration is the first process to start with, and post that you have to go with the enrollment in the courses. So now we have already done the 3 courses, and those who have already attended the previous webinars, we have shared the keys to register or enroll into this these courses online. So those who are joining first time, now we are again opening this the enrollment. So the first one is the smart manufacturing. That is an overview of the smart manufacturing, the course that is available on this website. You can use this key IFSM_OSM2020 to enroll yourself into this course. If you have missed it, you can attempt right now also. The second course that is open right now is the industrial overview of the industrial IoT. This webinar also we have concluded, and we have also added some of the additional content onto this website. So you can register for this course also, FSM IIOT 2020 is the key to register. So once you plan to enroll for these courses, it will ask for the registration key, and if you put this registration key, you will be enrolled into these courses. Now, today's session outline, I will just brief you how I'm going to take this session. Certainly, we will be starting with a very short quiz on the overview of the machine learning, the basic understanding of the subject that you have right now. And then we will discuss the role of machine learning in smart manufacturing implementation. Post that, we'll discuss the basics of the machine learning, certain algorithms. One important point I would like to make over here in this overview session, certainly we are not dwelling too much deep into the technology part and the implementation part. Those who want to just get familiar with this technology and the implementation scenarios, I think that would be the idea of this webinar. And those who are interested, we will be having one hands-on session towards the end of the webinar. And we are also planning a more extensive technological deep dive. I think I will announce towards the end of the session. So we will be just touching upon how the machine learning works, what are the various algorithms, how they work, without discussing any piece of the code in this webinar. Only towards the end of the webinar, when the demonstration works, we will be touching upon the basic codes, and later on, those who are interested further to learn these technologies, we will take them to the hands-on learning and programming aspect of the course. How the data can be prepared for the machine learning, we'll discuss for the same. The two important use case and practical application which are getting traction in the field of application of machine learning in manufacturing are the predictive maintenance one. So we'll discuss what are the steps for the predictive maintenance, and we'll also discuss the predictive quality analytics, so how that can be done. Then we'll discuss briefly about the smart machining, because some of the applications of the machine learning are very well applicable in the machining domain. So this is one of the area I will just discuss. And then there are few more applications of machine learning in manufacturing. So I will just touch upon briefly about what are the possible application of machine learning in manufacturing. And then last, we will be having a use case demonstration where the step-by-step implementation of ML will be shown to you. So I think this is the way I'm planning to conduct today's webinar. So let's start with the first part of the webinar, that is the quiz part. So those who are familiar, they can attempt the quiz through the poll questions thrown to them. And those who are new to this, I will just show the question on the screen, and then I will also be sharing a poll onto your screen to submit your answers. So let's start this. The first question for today's quiz is, you have to identify the definition of these three key technologies over here: artificial intelligence, machine learning, and deep learning. There are three definitions given on the right hand side. Approach in which artificial neural networks adapts and learn from vast amount of data. Algorithms with the ability to learn without being explicitly programmed. And third is the program with the ability to learn and reasons like humans. So this is the question you have to match, which is the correct definition of A, B, and C. So I'm just showing you the poll question to respond to this particular. So it is now available on your screen to respond. So these three terminologies looks quite similar, and that is how we most of the time keep them using interchangeably. So there is a minor difference into that. And if you look at the way this diagram has been drawn, has certain relevance into that. So if you understand the set theory, you will be able to understand the meaning of this diagram as well. Nice. Some of you are responding correctly to this. So they have a basic understanding about what artificial intelligence is, what machine learning is, and what deep learning talk about. I'm just waiting for another 5-10 seconds to respond. So those who are planning to respond, please submit your response quickly. So I'm happy that majority of you have responded correctly. It means that you understand the clear distinction between these three terminologies. That's good. So I'm just stopping the poll now. So if you see the responses that has been received, before showing the response, I will show you the answer for this is A3, B2 and C1. It means that artificial intelligence is about the programs with the ability to learn and reason like humans. B is algorithms with the ability to learn without being explicitly programmed. That is what the machine learning is. And the deep learning is an approach in artificial intelligence where we will be using neural networks and use a vast amount of data to learn. So that is what the correct definition. And if you see the results, 46% of you have mentioned correctly. So that's a really nice to start with this first question. Now we'll go to the next question. It's a very common sense-based question. Most of you have heard about the artificial neural network. So the question is, the inspiration is certainly the biology, but which part of the biology you find the inspiration over here? So I will just put the question. So ANN is basically inspired from genome, nerve cells, arteries, networks, DNA structure. And those who have a little interest into the domain of machine learning, I think ANN is a very common tool or the method or algorithm which is being used in the machine learning applications. So what I found, the right response is coming very well on the screen, and I'm happy that at least 80% of you have understood correctly the ANN part. At least they have a brief understanding about the technology here. But at the same time, I see there are around 23%, 25%, in fact, I should say, they're not getting the terminology correctly. So I'm just ending the poll now. And as the term itself says, neural network, and we all understand that neurons are the nerve cells. So the correct answer for this is the nerve cell. And the response is on your screen now. So 74% of you have responded correctly. It's a nerve cell. That's a neuron. Basically, the unit cell is known as neuron. And that from that, it is inspired to bring out this algorithm of artificial neural network. Good. So let's go to the next question in the series now. So this question is a little bit on the technology to just assess that to what level you understand the terminologies related to the machine learning. So remaining useful life of a machine can be predicted by, so these are some of the algorithms of machine learning. So I'm just launching the poll to respond. So this is very important because today we will be discussing briefly about these algorithms, the classification, the regression, the clustering. So what is the difference between these and what kind of results are being expected out of this? And when we talk about the remaining useful life of a machine, so I'm just ending the poll over here, and the correct answer is the regression, because we are expecting a numerical value out of this. So when we talk about the remaining useful life, and we are expecting a numerical value as an expected life of the machine, and that's the reason that regression is going to give me this kind of results. Unfortunately, most of you are saying all of them, and I think that is not expected here. So at least you need to make a distinction between these algorithms as a part of this learning. So let's go to the next question in the series. It's an interesting one. So if you see there's a graph shown in the slide, which is between the machine health and the years. So which machine requires the maintenance first after 3.5 years? The question is this. So I'm just throwing the question on your screen now. to respond. This is a very important understanding. Please respond it carefully because that reflects how you interpret the graphs. And I'm seeing all the 3 responses coming on my screen. I think that's not a good indicator here. Because when we talk about a complex subject or the deep subject like machine learning, the visualization is something is very important part of this. Even before you start any of the machine learning implementation, any project, we should be good at the visualization and interpret the results properly. So I'm just waiting for another 5-10 seconds to respond to this question. So the majority of you have answered it correctly, but still I'm seeing there is an equal representation for the wrong answer as well. So I'm just ending the poll here. Now, when I talk about the machine which require maintenance, it means that the health of that machine is falling drastically, or I should say the falling or deteriorating much faster than other machines. And that's how it require an attention over here for the maintenance activity. So if I just see the graph at 3.5 years, and most of you have responded correctly, the machine that requires maintenance or the first attention for the maintenance is grinding machine, because the steepest the graph it is, as you see that machine health is falling in a much steepest way with the grinding machine. And you need to attend it first for the maintenance as compared to the lathe and milling machines. So I'm not sure the answers are also showing lathe and milling machine, what idea they have in mind with respect to this question. Good, let's go to the next question in the series. So the correct answer is grinding over here. Little bit mathematics, not too deep, but I just want to touch upon this also. This aspect is very important because if you are thinking about entering into the domain of machine learning, we should have some idea about the geometry part here. So I'm just launching this question on your screen. There's an equation shown over here, and you have to just find out what exactly this represents. So I know that you forgot some of the mathematics, but as we expect that during the machine learning, we are not expecting that you should be at a graduate or the postgraduate or PhD in mathematics, but at least we will be expecting you will be familiar with the high school level at least, or the secondary level mathematics. So that is the idea, to understand where exactly you are. Good, I think I'm getting the right response as well. And I'm happy that at least you remember those equations which you have studied as part of geometry in the class 11th and 12th. Because some of these basic things are required. As I said, it's not expected that you are master of mathematics to attempt any machine learning use case, but at least you will be familiar with the basic understanding about these graphs and the equations. Fine, so I will be stopping this poll right now. And I see, before I show the response, I just want to show what exactly this equation represents. This equation represents a straight line. And if you see that this is the representation of the straight line here. And by just looking at this line, now you can figure it out. The y increases as x decreases, because this is a negative slope of this line. And I see that 39% of you have marked it correctly. But I'm really surprised to see the other two options which are not good here. Anything which relates y and x doesn't mean that y and x are independent. first of all, this observation is totally wrong here, because if I'm connecting them with an equation, it means one of them is independent, but the second variable is a dependent variable. So both cannot be independent. And when I talk about the option C, which has been marked here 26%, the rate of change of y. So now please understand the slope, meaning of the slope of a line. So rate of change is not a function of x. Y is a function of x. Rate of change of y is not a function of, because slope of this line is constant. So I think these are the two things. So what I found, more than 50% of you have not understood the equation of a line. So please just brush up these basic things before we take deep into the technology further. We'll come to the next question now. It's a very interesting one. So there are certain examples where you can use machine learning, but I just put the not in the bold, so that you have to identify where the machine learning preferably cannot be used or will not be using machine learning. So if you are reading about machine learning, you will be reading about the possible applications of the machine learning in manufacturing. And from that understanding, we should come out with what would be the right answer for this. Fine, so let's wait for 10 more seconds to close this option for this question. Please note the word not written over there, because I just want to identify the application where the machine learning cannot be used or preferably not be used. Okay, so I got approximately 75% of the responses. So I'm ending the poll over here. So most of the time we found the application of machine learning is in prediction and forecasting. So certainly from that term itself, once you see that if you are predicting something, if you are forecasting something, that is certainly a good use case for the machine learning. And wherever you see there's a deterministic way of solving the equation, solving the, or writing something or doing something, we will not prefer to use machine learning in those cases. So the correct answer for this is CNC part program generation, because this is more deterministic activity. We need not to put in a machine learning for its application. And I'm happy that 47% of you have responded correctly over here. But other forecast demand is certainly one of the good application of machine learning. We cannot say that we cannot use it. And similarly with the predict product quality and then predict tool we are in machining is one of the most important application for the machine learning. So let's go to the next question here. Just to get a quick glimpse whether you are learning machine learning or you have some idea about the Python or not. So just to extract that number from here. So there's nothing if you are not able to respond to this, but the idea is to just get an information whether you are familiar with these libraries which are being listed on the left hand side. So these are the Python libraries which are commonly used for machine learning applications or related applications. You need to find out which library is doing what, or it's helping in which part of implementation. So there are the options shown over here. You have to match the correct option. And these are the most popular library. In fact, those who just step in into the Python itself, we just do the one experiment with the Python machine learning, they will be able to know about these libraries. So if you have done anything into that, I think you can respond to this. If you are not, you can skip this also, that is fine. If you are not familiar with any of these libraries and you are just starting the machine learning part, that will also be okay at this moment. Good. So I'm not getting much response over here, but among whatever I have received, I will just stop the poll right now. And I will show you what is the correct response before I just show you the answer. So NumPy is basically the mathematical functions to operate the large array of data. It's mostly to deal with the arrays. Pandas is basically a library for data structure and data analysis. Scikit-learn is the core library in Python for the machine learning. So all the regression, classification, clustering, all these algorithms you will find in this scikit-learn, that is the machine learning, primary machine learning library. And Seaborn is just a data visualization library. So I think with this, the correct answer is D. And I found 41% those who responded have marked it correctly. So it's really nice. At least you are familiar with these basic terms over here. Now it's a last question here, more from a perspective of what impression you have about implementing machine learning project in an organization. So I will just launching this last question to you to respond. Please note the term lead. To lead a machine learning project in an organization, you need whom? Who is the person to lead a machine learning project in an organization? So tomorrow, if you are planning to implement a machine learning project, and if you are responsible for that organization, to whom you will give a responsibility for this? Certainly, all of them will be playing some role in the overall implementation of machine learning, but the question is about who will take the lead, who would be the project leader in this case. Good, I am getting a good responses over here. I am again waiting for few more seconds to get more responses right now. So those who are specifically from manufacturing industry, they can at least select the option what they have in their mind right now. Then I will share you the myth that all of us have, means who is the person responsible for implementing machine learning project in an organization. Good, so I'm stopping the poll right now, and this is what I was surprised also, and I was expecting also. The most of the time, because the term itself says data science is involved a lot, and that is what the obvious thing that we all understand, that data scientist is the person who will lead these kind of projects in an organization. So I will share you the result, and that is what is being reflected in the responses also. So data scientists, 47% of you agree that you need a data scientist to lead this kind of a project. And just take my word, certainly you are planning to fail any of the implementation of machine learning if you are just going with the data scientist, because he doesn't understand any of the application outcomes. And if you made him responsible for implementing any of the machine learning project, he will be playing some role in the implementation, but he cannot be the person who lead the machine learning project in the organization. So the correct answer for this question is certainly the manager with a domain knowledge. And I'm happy that 46% of you have responded correctly on this question. But this is very important to understand, because most of the time we believe that we need data scientists. We need those kind of people who have deep understanding about these algorithms. Then only we will be in a position to start any of the machine learning implementation. I think that barrier I should break over here before we start the course itself. So the correct answer for this is the manager with a domain knowledge is the person who will be leading the machine learning projects. So I will stop the poll part over here. It's nice. I think I get quite a good insight from your responses about this topic. So let's start this course on the overview of machine learning, specifically to the manufacturing, because I will be discussing the application and approach towards manufacturing only. So normally when we talk about the digital transformation journey, I'm just try to show you where exactly the machine learning is playing a role. So as we talk about the digital enterprise, we will be mostly dealing with the digital design, digital manufacturing, and digital products basically. And on one hand, you see that they are connected with a supply network, and the thread that is connecting all of them is basically the digital thread. So if I just magnify this chart, I will see that the implementation of the data science and management, data pathways, and AI is basically a part of a digital thread implementation, other than what other options are shown over here. So I'm not going in deep into them, but idea to show this chart is basically we are keen to implement this technology in the digital thread platform only. Now, when we talk about the foundation for smart manufacturing, I will just touch upon this aspect because most of you are planning to implement this. We will be starting the basic foundation from the machine upgrade. That is how the course has been planned, and we keep on doing these webinars, we keep on discussing these aspects. So first thing is certainly the equipment part, getting the connectivity and the sensors and actuators in place to get the real-time data. And that is basically possible with the basic implementation of the automation. Then comes the next layer of implementation, which will be building a foundation for the database supervision. We are not still talking about the learning, where we will be using the technologies like IIoT to get the data visualized and then representation of the information. And this there the role of the IIT come into picture. So when you do implementation of the automation, and the next level when you implement IIoT, which will establish the connectivity and bring out the data onto the dashboard, that is the next level of the implementation of the smart manufacturing. And when we talk, when we have completed these two foundations, then basically we will build the foundation for the learning systems over here. And there we will be using machine learning algorithms to diagnose the problems and to come out with the corrective actions. So that is how the step by step we are building the foundation for implementation of the smart manufacturing. And post that you will be building a foundation for your business expansion, and that is possible with the connected enterprises. Now, let's go back into the fundamentals of the machine learning. As we all understand, the genesis of this kind of an approach is started with the biological neuron, and then not going into the biology and the details of this neuron, but basic structure from where the analogy has been taken up to build the unit for implementing artificial neural networks is basically this perceptron. The same way these dendrites and synapses are being used in the human or in the biological neuron, same mathematics has been used over here to use the inputs, put them with a weight, and finally we will be getting the weight added and weighted average of all the inputs over here with a bias, and finally there would be an activation function which will generate the output, and this output is being compared with what is being expected, and certainly there would be a modification happen, or you will be tuning the model further. And the same is then grown into the multiple intermediate or hidden layers here, which is talking about the deep learning part. So I will not be going into that, but basic thing I just want to explain here, that the basis of the artificial neural network is in the biology, and that is what you have responded in the first question in the quiz also. So when we talk about the machine learning, certainly we are looking forward for the ability inside the computers to learn without writing a piece, without writing explicitly the steps of that program. And that is what I'm just going to explain you over here. If you have done any of the programming earlier, you know that if I am using this kind of a programming approach, that I have defined a relationship between the y and x, and if I give an input value to the x, and I will be getting in a value of y. This is what I'm just giving a step-by-step approach to implement any of the algorithm in the computer program today. So I will be writing all these steps for the execution. And when we talk about the machine learning approach, we will not be writing these steps. What we want, that there is a data available to me, and I will be using that data to come out with a model. And this model is helping me in generating the output. So in that case, I will be using multiple data sets. This I'm using again another way that 3 can be written. And finally, this model is able to give me the output 3. So that way, I have not written any sequential programming over here. What I have done, I have just trained a model with the various data set over here. And then I can query that if I write a 3 in a new way, and I can ask this model what would be the output, then it will be able to give me this output 3. It means that I made this algorithm that learned from the observational data, because I keep on teaching this model the way we teach even the kids also, that this is the way you should write tree. And you see that everyone is writing tree differently. So if I write a very sequential procedural code, it will not be able to find out any of the handwriting recognition part over here. And this is the way that model will be predict the value 3 in this case. And we, most of the programming in machine learning we will be doing in this fashion only. So we are writing the programs to build the model. We are not writing the programs to write the sequential steps. That's a basic difference over here. Before I go ahead, let's understand the key terminology related to the machine learning. So we always start with a data set that is available to us. So the journey on the machine learning starts with the data only, because we should have some data to start with. And this data can be in Excel file, CSV file, or in a database somewhere. This is just in a quick database, the quick set of the data which is coming from a machining application, where you have monitored some of the parameters and then you monitor the tool breakage. Now in this case, one part of the data which is being marked over here is the training data. And the data which is being given as an input, or the parameters which are being controlled over here and monitored. And there's an outcome which is being observed over here. So this outcome is known as target variable. And we will be using this outcome for the prediction also. So we would like to predict the tool breakage by implementing this algorithm. So these are the basic things we need to understand. There is a set of the data which we call as a training data, and there is a target variable, which is the label that has been given to that particular observation. So in this case, all these vertical columns over here, so depth of cut, feed rate, spindle speed, these are known as attributes. So these are the attributes I am capturing while conducting the experiment, or while the machine is running, I am capturing these attributes. Then there's a observation in each row over here. So one experiment, one data point that has been captured over here, we call it an observation here. So that is the basic terminology of machine learning, and we will be using whenever we discuss the implementation part. Now, when talk about the problem solving process in machine learning, certainly it starts with the data acquisition, and many of you may be familiar with this workflow also. So data has to be acquired in the initial stage, and then post that we will be cleaning the data, because all the data that has been received may not be in a way that you will be able to use it. Sometimes you will get a blank character, sometimes it may not be appearing at all. So you will get all sort of the data. A cleaning exercise is must before you take up this data, because data is the most valuable thing that is going inside this machine learning. If you end up in giving the wrong data, the interpretation, the results will also be prone to wrong. And then in that case, I will just split the data so that I will take out some part of the data for testing, and I will use the remaining part of the data for training. So first of all, I will train the model with this trained data set. So I will be splitting this data which is being cleaned in the two parts. One is the test data, another is the trained data. And from the trained data, I will be developing a model. So the model get trained with the training data set. And then what I will do, I will just evaluate the model with the test data. Whatever I have just taken out for testing. So whatever model has been developed based on the training part, I will be evaluating that model over here. And if it is not giving me the right output, I will be just adjusting the model parameters. So this cycle will continue by tuning the model again and again till we get a final model which can be deployed. I think once we have completed the training part, the model is ready for the deployment. So that is the way it will be done. So this way of learning is basically known as supervised learning, because we have a training data set. When I say training data set, means outcome is known to you. You know the outcome. So there's an observation and you know the outcome, whether your tool break or not, you know the outcome. So that kind of data set we call it a training data set, where input is also known, where output is also known. I will be just using that data to training my model. So once that happens, we call this kind of a learning as a supervised learning, because someone is supervising that and training you, this is correct, this is not correct. There's another way of learning where we don't have this kind of a data set where somebody put the labels onto that. So in that case, the rest of the steps remain same, but I'm not splitting the data. I will just using the same data for training the model. And then post that the outcome will be there. But I will be just tuning the model parameters. I will not be just adjusting against the outcome of the test data. So I will be just training this model or the fine tuning this model. And once I found this will be able to do a correct representation of the data, or correct outcome is now observed in this case, we will be stopping this training part and we will be just deploying this model. We call this an unsupervised learning. Now, training here doesn't happen with the labeled data. So that is again one point I'm just going to make over here. I will show you some of the algorithms where the unsupervised learning has been implemented. Now, when I come for this, the idea is that we will be more focusing about improving the situational intelligence, performance, and reliability by using these machine learning algorithms. So I'm just giving you a broad classification over here. So machine learning, as we have seen that there's a way that we can implement the supervised learning. The most important requirement for supervised learning is that you should have a labeled data. Means I will be able to tag the outcome also. I will be able to identify the outcome in this kind of a data itself. And we call that outcome as labeled here. Then we will be having two types of supervised learning. One is certainly the classification. The classification between the man and woman, cat and dog, defective, non-defective, that kind of a classification can happen. So labels are here categorical. You will be placing them in certain category. And the other way is that you will be having a regression where the labels are continuous. It means there's an outcome which is continuous, and you will be able to find out a numerical value coming out of this. So that is the regression model. The other way is that you will be using unsupervised learning, but we don't have any historical labels for the data. You have the data. Please note that it doesn't mean that you don't have any data here. We have the data, but that has not been identified, which is good or bad. That kind of data is available to you. So you don't have historical labels for your data. There is a data available. And then I will be using that data to just making a cluster of the similar groups. So I'm not distinguishing between these clusters, but I'm just identifying which are the broad clusters or which are the similar groups in this data. And then later on, we will be using this information for further maybe the regression part or the classification one. Now, most important aspect when we talk about the machine learning implementation, we will be talking about how to spot a machine learning opportunity. And this is, I'm talking about from a broader perspective of its implementation, means how you will be planning to implement the machine learning. Because this is the one of the most important requirement. Finding a person or algorithm is much easier than finding an opportunity for implementing a machine learning. So there are many challenges in getting started with machine learning, and the most of the challenges we see that either we don't have a data scientist available to do the implementation. That is how you always see that these are the person who will lead these projects. But other side, the most important aspect is that the spot AI opportunities. We don't see much AI opportunities, or we don't see much machine learning opportunities in the day-to-day implementations. I think these two challenges are equally responsible for the penetration of the machine learning. So when I say finding out the opportunity for machine learning implementation, this is the most important part. I need to spot out where is the opportunity to put an AI implementation or the machine learning implementation. And the most important business skill in this direction is that you should have some intuition or some understanding how machine learning algorithm work. I'm again saying intuition for this. I'm not again saying you will be familiar with the in-depth understanding of these algorithms, but at least you should have some intuition or understanding. As I say, if you understand what exactly the classification means, what exactly the regression means, what is the clustering means, and the problem I'm talking about, in which category this can fall into, what sort of data I will be having, how can that be applied? I think that's a reason that if you have that kind of a business skill, you will be more, you will be able to implement these machine learning projects in a much better way. So let's have a quick understanding how it works. So you have one input A, and certainly you would look forward for a response coming out of these algorithms. That is a very basic mathematics over here. So you provide some input data, and I'm looking forward for some response coming out of these algorithms. And this is the case with the basic algebra also. So once you have understanding about the high school mathematics, you will understand equation of a straight line. I'm sure that all of you even remember today this equation of a straight line where we have y is equal to mx plus b. Now there are the, so y is a dependent variable, x is an independent variable, m is the slope of a line, b is the intercept. Just for a quick revision, I just repeated that. But this line represents one relationship between the y and x. So it means that this algebraic equation represents some relationship between y and x. And this relationship is also defined by this slope and the intercept over here. Now, whenever we solve these kind of an equations, let's take an example, y is equal to 2x plus 1. Though I have a relation, I understand there is a relationship between x and y. And once I put an x is equal to 1, I will deterministically get y is equal to 3. I think that's a way that we solve these equations and for the problem which are deterministic in nature. So once you have a very clearly defined relationship or understanding between x and y, you will be able to find what should be the value of the y for a given value of x. That is the common approach of solving equations. Now, when we talk about the machine learning, we always have a data. We don't have any relationship available or known between y and x. So for a given value of x, you will be having a value of y here. And what I'm supposed to do, earlier the equation I'm solving for y for a given x. If you see that, I'm solving an equation for y for a given x, and m and b are known to me. The slope and intercepts are known to me. When I'm talking about the data that I have, I know that there's a relationship like this between these two variables, but here I will be solving this equation for m and b. I'm not solving this equation for x and y because x and y are known to me. So this is just a reverse of what has been done in the previous slide. Now, in this case, we will look forward for the relationship between m and b. So what I will do, I will plot all this data between y and x. And in that case, I'll try to fit a line which will be representing this spread of this data more accurately. And once I am able to fit this line, I will be able to find out the slope of this line, which will give me m. And then I will be able to find out the intercept also. So what I have done, I have just started with the data equation. The relationship remain known, which is in a linear relationship over here. But I will be finding out the slope and the intercept from this equation. And if you see that, so once I know this relationship, this red line is now known to me for any given, any unknown value, or I should say that the first time this x value is being noticed over here, I can find out what is the corresponding y value, because now I know the relationship between y and x. So before that, you have to just do the fit, and from there I will be able to figure out the relationship. So this is a supervised learning because I have used the known data sets over here to plot them first. From there, I'll find out a relationship where I will be able to know the variables m and b here. And this is known as linear regression. So this is one of the algorithm in a supervised learning. If you see that as mathematics wise, this is not that complex. If you know the basic equation of a line, and you will understand the good mathematics behind the linear regression. So that is one of the algorithms. If you are able to do implementation for linear regression, I think you know pretty well machine learning now. Now let's see that the important part to understand here, this finding is probabilistic. It can never be 100%. I cannot say that what is the outcome against a given value of x of the y, this is 100% or this is deterministic. We always have to keep in mind while we are interpreting the results coming out of the machine learning. So there we need to understand these results are always probabilistic, and there is certain confidence limit or confidence level in that particular prediction. So we should not go with the prediction values as it is. And there comes the knowledge of a domain. So it's very important to understand what is the outcome and to what extent I am going to use this outcome here. Now let's see that most of the problems I have just explained the regression in a much simpler way we have seen in the previous slide. But most of the machine learning problem can't be reduced to a simple equation like this, y is equal to mx plus b. So I think that there's a challenge. So once you understand the basic things, certainly you can extend the learning beyond this, so that there comes the relationship between the multiple variables. Now, y is not just dependent on x. Y is certainly dependent on many x variables, but all these relationships are linear. That is very important over here. And then you will also be having an error term here. So these are some of the variables over here. So y is a dependent variable. Your x are independent variables here, and which you are exploring here. And then these are the different intercepts for different variables, and sigma, this epsilon is the error. And this kind of a representation is known as multiple linear regression, MLR. So once you understand basic mathematics of linear regression, certainly there are quite a good algorithms are available. There are certain libraries are available. So you need not to solve this equation on your own. These algorithms will help you in solving this. But idea is that, as I have shown that table in this previous slide also, you have many attributes basically which are predicting that tool is going to fail. Now, in that case, we need to fit this kind of a linear, multiple linear regression equation. Now, when we talk about spotting in a the machine learning opportunity, first thing we need to check in the organization or the application in day-to-day observations. What are some outcomes worth guessing? Means where exactly you can make some guess about the outcome. So any kind of an activity that you find that you will be able to guess this is the possible outcome in this case. Then the next question is, do we have necessary data to do this kind of implementation? So whether you have that data for supervised learning or not. So let me give an example over here, which is a very common example in the machine learning domain, which is in predicting the house prices. So let's see that. First of all, I am looking forward for the data that is being made available to me. So I just capture the data which is being shown over here for some of the houses which are being tagged over here. These prices are known. Now, what exactly I have captured over here? The price tag which is being shown over here, and there are a lot of attributes related to these type of houses. The location, the size, there are many more attributes which governs the price of these houses. So what I have done, I have captured the attributes, and the price is the target variable over here. And I will use this data further for implementing the linear regression. So what I have done, then I have plotted this this data set which is being made available, and as I explained, I will fit a line over here which is a linear representation over here. So house size and a price, because I am going to put a 2D relationship only for one variable here. So one house size and price, I can represent that variable over here. But using this regression, now my question is that can I predict the price of a different house which is not being over here? And there comes the use of an intelligence over here. So that intelligence that is being built with the set of this data being captured over here. So it captured the intelligence in identifying the attributes responsible for those prices. And I will be using that model which is being learned now to predict the house of an unknown variable here. So it's a completely unknown house which is not being visited. But if I put the attributes of this house, my model is able to give me the target price for this. So as I said, this is not 100% true. So this is just a tentative indication for that price. When you go for purchase and negotiation, the price will vary also. Now, we already know that organizations are using a lot of statistical tool today to predict the some of these activities. For example, predict the future product sales. Sale forecasting is one of the way that people are predicting. Remaining useful life of the assets, people are already predicting that. So point is that statistics behind these different algorithms vary in the complexity the way you want to apply. As I've explained that I started with a basic linear regression equation in one variable, and then you said that if you have 10 variables, certainly the algorithm will be changing. And as we see more and more complex implementation of these algorithms, there lies the challenge over here. And then the predictions that are coming out, they are varying, and we need to interpret this prediction within a confidence rates or the confidence level. Means you will not be giving much weightage to the value that is coming out within a 30-40% confidence level. You should be understanding the outcome of these algorithms also. I think that's an important part over here. So we have seen some of the prediction algorithms in the previous slide, and so certainly the one that I've shown is the house problem is there. So supervised learning can also be used for the classification, because if you see the prediction of the house price, I will be interested in an exact number, or there would be a certain value which is being represented in the money, that is this so many lakhs is the price of that house. Now when we talk about the classification, that is another way of supervised learning. I will be having a data which spread like this. Now you see the complexity that is coming out over here. Some of the data points are even mixing between the two sets also. There could be a possibility your data will be basically visualized like this. So you will be having a class 0 and class 1 basically represented like this. Sometimes you have a very clear division between these two. So that is how the classification works. And then if you see that binary classification is even easier, as you go with more and more classifications basically, or classifying them into more and more independent groups, the problem complexity will keep on rising. So I'm just trying to give you a quick glimpse of the simplest part of the problem. At the same time, the algorithm will go on getting complex as you indicate as you increase the number of groups. In case of a classification, the simple problem every one of us understand is the spam filtering actually. So that's one of the good example of the classification. So any of the incoming mail now can be classified as a spam or ham. Ham is basically that's a correct mail. So that will go to the inbox and the spam mail will go to the folder. And all of us have this experience today. How this has been built up? Initially, the mails are being tagged. Basically, these are the spam, and then people start identifying what are the keywords in those mails, which basically classify them into a spam, and the algorithm keep on learning. Even today, also we will be training some of those mails. Also, many times we find there's a mail in the spam folder. We indicate this is to be in inbox, and every such input captured is basically training the model. Another example is basically just a classification of the type of vehicles over here. So if you see here, the algorithms, classification algorithms are being used to identify whether it's in a car or bus. And there's a confidence level indicated over here. So if you see that's a 89%, 86%, 60%, 70%. So while interpreting the results, it's very important to take into account these confidence levels. The perception task, most of the time when we use vision and then perception build out of the vision and training a computers is recognizing these objects. So and most of these algorithms are classification algorithms. Many times we see that it's classified, there's a child, there's the man, there's a woman, and even it's identifying there's an animal, there's a cat, there's a dog. All these are the classification problems basically here. Let's talk about a simplest algorithm which is being used for classification. That's an k nearest neighbor. So let's take an example of a machining because we are talking about manufacturing. So in this machine, I would like to implement this classification algorithm to find out the fault over here. So what I will do, I will just put a vibration sensor onto the machine. So I will be monitoring the vibration parameters. Then I will also be adding an energy meter to this machine to monitor the energy consumption. Now what I will do once I capture the data out of this observation, so I put the vibration amplitude on x-axis and I will put this peak motor current that is being observed and captured from this energy meter. And what I did then, I will be just plotting that data. So I found some of these data points over here which indicate that machine is working okay. So I just put all those observations and then I found these are the set which is now indicating the machine is performing well. This is another set of the data which indicate that there's going to be a problem with the machine or there could be a possible anomaly detected into the machine. So when you have these two kind of a data which is being available to you, now this is basically used for the training. Initially we train this model with this kind of a data set. So for certain vibration amplitude and the motor current relationship, we found that for a large motor current, but the vibration is not there, it's fine. We are accepting this is okay. But many times, even at the low current, if I see there's a large vibration amplitude, I will find this is an anomalous behavior. So that is the way this can be interpreted. I'm just showing you with the two variables only. And now I get a new point over here. This green point is the one I want to find out whether this is a normal status or there is an anomaly in this observation. After training this new data point, how I find with this k nearest neighbor, there's an algorithm which says that I have to find out so if I'm using a k equal to 3 here, you can choose any k value. This will be learned through the experience only. So when I say I have to check the distance of the 3 nearest neighbor, so this new point, I will be checking the distance of 3 nearest neighbor to this. So one nearest neighbor will be this point, second nearest neighbor to this point is then, third nearest neighbor to this point is this. So based on these 3 nearest neighbors, because depending on the k is equal to 3, you can take k is equal to 5 also, you can take k is equal to 7 or even more also, that is fine. Because I'm just giving you an idea about the algorithm. So once I check the distance of data points, the nearest neighbor around this particular new point, then I found 2 of the nearest data points are belonging to the anomalous behavior. So then this can be classified as an anomalous behavior. That's a way that the algorithm works. So this k nearest neighbor is the simplest classification algorithm. Once you have a trained data and the new data can be checked in this manner, you will find out where exactly is a close resemblance, whether it is having a close resemblance with the anomalous data or with the normal data. So that way you can predict that this is an anomaly detected into the machine. This is just quick example of this k nearest neighbor. When we talk about the supervised learning, we will be talking about these two things. One is the regression, where we are fitting an equation over here and we will be getting an output which is a numerical value coming out of this. The second one is the classification. So you will be just finding out which group it belongs to. And most of the predictive maintenance problem, the way I have explained in the previous slide, so most of the predictive maintenance problems are the supervised learning problems. Means either I will be classifying that as a normal behavior or anomalous behavior, that the way I have explained in the previous slide, or you will be using this kind of fit for predicting the useful life of the machine. So then you will be able to find out what is the useful life, and this regression can be used to predict that. So that is the way the predictive maintenance can be implemented. When we talk about the unsupervised learning, now I have these data points, but I don't have any idea about these data points, what they represents. So in that case, I will be just making the groups of this data, which is just clustering them. So this is one cluster. So classification and clustering have this difference. Classifications, we know that where exactly I'm going to classify, whether this is a car or a bike, I am already putting them into one of the category. Here we are putting them in a group, but we don't know what this group indicates. So that is what is known as unsupervised way of learning, and that is what the clustering. So we are just clustering or making the data into the groups. So when we train that, we are identifying these clusters coming out. And when you get these clusters, we'll draw the inferences from this data set, and without knowing the labels, we don't know that. And later on, I will be using this to find out which indicate that trend, which is the anomalous behavior in this case. So initially for exploratory, we will be using this kind of an unsupervised learning approach. And once we are able to identify the clusters, then you can tag those clusters as it is. Let's quickly talk about the data preparation part. The machine learning normally deal with the data only. That is what we all understand. So quality of the input is very important. It's going to make a good impact on the output. So we are always concerned about the quality of the data that you are using for these learning algorithms, and same is the type of the data that you are using for this learning. So this understanding is very important over here. So let's talk about the predictive maintenance case again. So in this case, you need data. What type of data you look forward here? So we are looking forward for the failure data. So what is the data? Machine utilization data report, the failure report, the breakdown report, the maintenance reports. This kind of data is required over here. For predictive maintenance, we look forward for the failure events actually. And then we dig out the historical data about this machine performance and maintenance. That is the starting point data for the predictive maintenance. And we also look forward for the static or the specifications of the machine. So these are the data which are important to start with for the predictive maintenance problem. And then we look forward for the prediction of the future failures. This data is available for the past events only. So we look forward for the prediction of the future failures. Now, when we talk about the data preparation, the question that should be answered is that what question do we want the machine learning model to answer? Because certainly it cannot answer all type of questions. So we should be very clear what I'm just looking forward as a result of this machine learning implementation, what kind of questions it can answer, and whether we have the answer possible for this question or not using the data that is available to me. So is it possible to answer this particular question depending on what type of data I am having today? So that is very important. So first thing, what question this machine learning model to answer, and whether I have right set of the data to answer this question on, or whether is it possible to answer based on the data that I have. So that's the two important questions while preparing the data for the machines. Now, another important questions that we need to ask while collecting the data, while starting even the machine learning implementation, because data preparation is a very important exercise before we implement the machine learning. So let's take an example of a machine only again. First thing that we should have an understanding what type of failures happened on this machine. So that is the starting point to start with, because we are talking about the predictive maintenance. We should have some observation about the failure. Then we'll talk about which failure to predict. Now, there are many possible failures happen into this machine, but which type of failure is more prominent or for concern to me, and I would like to predict that type of failure with the machine learning. And for that particular type of failure, I need to find out whether this kind of failure happened all of a sudden, or this is a focused event. It happened after some time, or it will happen in a very slow decline manner. Means it's gradually, it's the behavior or the performance of this particular component deteriorating gradually actually. So that's about the slow decline part is there. Then we'll also look forward that which component is associated with this failure. So I'm just trying to respond to some of these questions before making a use case of implementing predictive maintenance for a machine. So now once I identify which failure to predict, and out of that I found out what nature of that failure, now I'm looking into which component is basically associated with this failure. And then I want which parameter to measure to monitor the performance or the outcome of this component. So if it is a component, running component, which parameter I should be monitoring, whether it's in a vibration, whether it's in a speed, whether it's a temperature that is to be monitored at a particular location. So which parameter to measure is the next question to be addressed. And finally, once I identify the parameter, the most important part is that what should be the accuracy of that measurement and what should be the frequency of capturing that data. I think that's a way only we will be, once we frame, once we are able to respond to these questions, now I identified which all data to be captured and which sensor I need to place onto this machine. Because the last question, if I am able to answer, means what data acquisition system is required and which sensors to be placed onto the machine, I will be able to address the right failure, and then I will be developing a model to predict the same. So predictive maintenance is certainly one of the most important application that we see for the machine learning. And we also find that this is the operation which is very expensive in the organizations. So the traditional way of predictive maintenance, if I describe quickly here, so I have a machine and then I will be having a PLC, or I will be running a SCADA program over there. I'll set some parameters over here for the setting the limit. So what I'm doing normally in the program, I set some human coded thresholds. I will set some rules also, and then set certain configuration programmed into this controller or this SCADA program. And that's a way, so nothing new about this, because those who are implementing this kind of programs, and they said they are already implementing some kind of a predictive maintenance, because as soon as the threshold value rises, I get an alert. And once I get an alert, I will be able to control it. So what's new about the machine learning? We already did this kind of an implementation in the program. So this is kind of a semi-manual approach. When I say semi-manual approach, means that I'm not able to capture the complex dynamical behavior or the pattern of the machinery, because today, whatever threshold I set, it may not be going to remain same. And then I need to find out the new patterns also. So this limit has to be changed over a period of time, and it's again depend on the intuition and the experience that you will be getting over here. The second thing is that contextual data is missing over here. Means for a particular operation, what is going on, I'm not bothered if I'm running this conveyor idle or not, if I'm running this particular type of job or not. That kind of contextual data is not available in this case. So manufacturing processes related data is not there. This threshold and this rules are independent of that. It's just capturing some of the parameters in the automated systems, and they will be just setting the threshold and limits on top of that. So when we talk about the machine learning approach over here, so again, we'll take the same equipment. Now I will be bringing out the OT data, the data coming from the sensors, data coming from the PLC, the historian, the SCADA. I will be just bringing out all the data here. I will also be combining the data coming from the IT. So which order it is, even the data coming from the MES, the quality data is also being captured over here. And also the data related to the manufacturing process information. So I will be feeding all the data, all these three data into the machine learning algorithm. So now I'm not just be dependent on one type of the data. I will be bringing out the OT data, IT data, as well as the manufacturing processes related data. And then this machine learning algorithm is going to give me an anomaly detection. So that is the way I will be looking for. I will be looking ahead for utilizing all the data available with respect to this particular equipment or the process to help me in identifying the pattern. And then do the before we detect and predict that, there should be a correlation testing, which will also be happening in this case. So when we talk about the machine learning, certainly we will be capturing a very large amount of the data from the machines. We will be analyzing them in the real time, and certainly we will be looking forward for the actionable responses coming out of that. So that is the way we will be able to implement the the predictive maintenance. And we will be monitoring health and behavior of each asset over here. So that we will be able to know before the malfunction happen or before the component go into the catastrophic failure or there will be a breakdown into the equipment, I will be able to find out the status of health. So if I'm monitoring the remaining useful life of the product or the particular component, I will be able to identify at what time I should look forward for the maintenance activity. The another application for this is the quality monitoring. I think that is what the predictive quality analytics is all about. The first one is more toward the machine and the equipment we are bothering about. Now I will be concerned about the product, because if I'm turning a product or if I'm producing a product, I will be concerned about the outcome of this product. So what I will do, I will again capture the relevant data. For example, in this turning process, I will be capturing the speed, feed, vibration, temperature, and energy, coolant. So there are many more parameters. Some of these parameters are related to the machine itself. Some of the parameters are being captured related to the workpiece also. And we will use this data. So for example, I will be utilizing this data. So I will be using some kind of a machine learning model over here to predict the roughness value or the waviness that is being achieved. So the quality is now being captured over here. Now, certainly I cannot, it's very important to monitor the real-time change in these parameters. So what I will do, I will train the model based on the observations being captured. For example, for certain speed, feed, or vibration, I will be able to find out the order of the roughness and waviness that I have observed or that I have captured here. And then what I will do, I will use this monitoring of the parameters, which are the passive indicator of the deterioration of the product quality. So machine learning predict the quality based on the data that may not be actually capturing the quality of the product, but it will be capturing the data related to the quality of the product. So that is the way it is very useful, and I will be able to save on the valuable production time, and I will be able to predict this quality deterioration. I will be able to save a lot of raw material for me. Quickly, I touch upon the smart machining, and that is what we understand the conventional machining processes. In this, operation conditions are not always ideal. So any kind of a threshold set will not be going to help me. In fact, it's always prone to these type of error. There would be a possibility of geometric errors, thermal deformation in the machine, elastic deformation of the bed of a machine itself. A lot of vibration level can be sensed over here. So I think these conditions keep on varying, means how you are operating the equipment. So what we look forward for the real-time optimization of the process parameters, and it will happen automatically. So when we talk about the smart machining, we will be talking about adjusting the parameters autonomously here, so that I will be optimizing the performance and I will be able to predict the quality and maintain the quality of the product. So this is just in a broad block diagram for implementing the smart machining. So there are various parameters being captured over here. So there are certain machine tool related parameters, some of the job specification related parameters over here. Then I will be using the sensing here. So force, vibration, thermal, energy consumption sensing will be done. Then you will be monitoring these parameters, and then you will be monitoring the health and process and system as well. You will also be finding the outcome related to the product quality, productivity. The most important part is that I am logging this data to a database. Then the role of a machine learning come into. So I'm just showing you where exactly the block diagram related to the machine learning you are plugging into this. So after this data is being received, I will be plugging this machine learning module here, which will be doing feature extraction, pre-processing, implementing some of these learning algorithm, and then decision making. And this decision making is then communicated back to the controller for the action. So that is the way smart machining can be implemented. Same is true with the milling process also, because many times we are concerned about the tool wear, the condition of the tool we are monitoring. That is very critical over here. And the classification algorithms are the one which is helping us in finding out the tool wear monitoring. So we look forward for the process parameter optimization for the cost reduction through the energy consumption data also. So we will be able to reduce the consumption of energy by changing the parameters to the machine. At the same time, we'll also be improving the quality of the product. So we will be monitoring the roughness, and we will be immediately come to know if there is any deformation happening into the product itself. So people have done a lot of experimentation on that. This table is just to show you the way it has been implemented. So people have used this machine learning for various applications related to the tool wear monitoring, tool breakage detections, energy consumption prediction, remaining useful life of the machine, even the remaining useful life of the tool also, even the surface roughness prediction on the part, and they have captured these inputs for predicting these things. And the most important aspect is that this is the level of the accuracy they are able to predict by using these algorithms. So that's basically a good indicator over here to adapt some of these algorithms. This is just a quick report from PwC, which is now published in 2020 only, and it is basically projecting the next 5 years of application of these technologies. So I'm just highlighting here how the machine learning technologies are going to impact the manufacturing. So this is what the prediction is. So we see that the predictive maintenance is at the highest level. So currently we have 28%, and we look forward for that there's a growth of 38%. So in the next 5 years, more and more people are going to use machine learning technologies for the predictive maintenance. Same way for the process visualization and automation, there's going to be a significant rise over here. I'm just highlighting some of the key things related to the technology we are discussing. And most important aspect is the digital twin part over here. So these are the some of the technologies which are going to see a high rise in next 5 years of the implementation. It's the right time to start understanding about these technologies, and to some extent start learning about these technologies also. Now I will touch upon the basic algorithms and some of the use cases, but let me just quickly give you a glimpse about the other machine learning use cases for the manufacturing. Now deep learning can power the defect detection to a great extent. Let me just explain you this. So I think vision as well as the machine learning algorithms and the kind of an hardware available today in the form of GPUs will be helping us in implementing these algorithms. So image classification, object detection, and certainly I will be using this to train my visual inspection system. So one of the good application is the defect detection through the visual inspection, and then this will be helping me in detecting the defects. Quick example, if you see here, this is the vision based detection of the crack in the cap or the sealing of these bottles. So if the bottles are moving at a fast speed on the conveyor, so my vision system is now able to detect the crack on these bottles immediately, as I had trained the system for the same. And I can find out, I can remove this bottle before it going to impact in other way. Same way, if you see that even for the safety also, I think most of us have seen some of the examples being implemented in the machine learning is to detect the face mask today in the corona, in the COVID domain. We see that people are now using the similar algorithms to find out who is wearing the mask, who is not wearing the mask. So these kind of violations can be detected because depending on the area which is sensitive to the safety part, so vision can safely detect the person is wearing helmet, the person is not wearing the helmet. This one I have already discussed to a stretch, that predictive maintenance with machine learning is one of the most important use case over here. So you can predict the remaining useful life with the regression models. You can predict the failure within a predefined time span with the classification models. And you can also detect the anomalous behavior of the machines. That is what I have mentioned. Another use case is basically the machine learning powered digital twins. So that is the next level of implementation where we will be having a copy or the virtual copy of the physical production system. And I will be able to teach this digital twin model with the machine learning algorithms to optimize the physical system. And I will be able to do the real-time diagnostic and evaluation of the production process, because most of these can be implemented on this digital twin itself. So I will be predicting about my physical system once I implement the digital twin, and this digital twin is being trained with the machine learning algorithms only. So when you see the technologies that are helping us in implementing the digital twin are the connectivity and the CPS, and on top of that there's a machine learning models which are building a more real-time information about the physical system. So you will be able to predict and visualize the product performance with the digital twin. So ML algorithms are basically used to optimize some of these production scheduling and the quality improvement measures. So before you even implement those measures, you will be able to use the digital twin to find out the impact of those measures also. So that is the example of this machine learning powered digital twins. Another domain is the generative design for the manufacturing, because it's going to impact the designs also. Machine learning based generative design concept is a new concept where we will be coming out with the number of designs based on the inputs being given. So normally when we compare the design, these are a few numbers in the in our case. Maybe we'll create 4 or 5 designs to compare and evaluate and maybe analyze. When we implement the machine learning in the generative design, so there are advanced deep learning algorithms being used in generative designs. You come out with n number of designs with some variation. So there's an optimization happening once you give an input that you need such a weight, such a size of the products, these materials to be used, certain operating conditions you can define. So now your system is going to do a design activity for you, and it will be producing many results, and then post that you can also do the analysis on that and finally come out with a new product design which has never been thought of. People are not even able to conceive this kind of a design with the equal strength, with a similar lightweight kind of a thing. So and these designs are quite viable in the era when we are talking about the additive manufacturing. So that way the generative design is basically giving me an option to explore multiple designs basically for a particular concept. So normally we conceive the design, but using the deep learning algorithm, now softwares are able to do that conceptualization for me and suggest multiple designs for me, and out of that I can choose one to take it further based on the analysis that we want to do. I can produce one prototype also, and then we'll test that. So I think it's also optimizing a lot of things in implementing this design. So that's a new approach of generative design for smart manufacturing. ML-based energy consumption is another domain for implementation here. So it will help us in finding out the patterns and trends in the energy consumption. We'll also be able to predict the future energy consumption requirement, estimate the energy bills for you. Then you will be able to optimize and based on the data. So once you are getting a data to you, and then data-driven energy optimization measures can be implemented in the organizations. That is what another area where we can implement the machine learning algorithms. The most important part is the supply chain. I think there it's also going to impact a lot. So mainly in the demand forecasting, people are using a lot of machine learning models. These kind of algorithms are in use, so I'm not going to discuss them in detail, but once you have a machine learning algorithms, I will be able to analyze the customer behavior, the pattern and trends, and that will helping us in designing the new products, deciding the new logistics, planning that logistic part, optimizing my manufacturing processes also. So other than this, these three advantages the manufacturer are going to have, we will also be able to optimize the transportation part, because these algorithms will help you in assessing the shipments and the deliverables and their impacts. It will also be used in the route optimization, and people are using a lot of these algorithms for the logistic route optimization. And the most important part is the warehouse control. So these kind of robots are also being used. So they are scanning the inventory as they are keep on moving around. So the same kind of an algorithm which are based on computer vision are able to detect the kind of an inventory check over here. And whenever there's a shortage of the stock or the excess of the stock, timely replenishment can be done. So I think these are some of the quite a good use cases for the ML implementation in machine learning. I think that is all from my side for today. I think the next session we had planned for a machine learning demonstration. So we have Dr. Souvik Chatterjee here to take up the next 30 minutes of the session for demonstration to you. And then I will come back to you about the next step part here. So thanks a lot for your patient listening. I will now just going to hand over to Souvik and stop sharing my screen. Just a minute, I will just stop.
Thank you, Professor Jha.
Yeah, Souvik, let me see if you are able to share screen now.
Yeah.
Yeah, you can share now your screen.
Mm-hmm.
Are you able to share your screen? Yes, yes,
Yeah.
it is coming.
Is visible? Okay.
Yeah, it's visible now.
Okay. Okay. Thank you so much, sir. So what we'll do is quickly go over a used case sort of a situation for predictive maintenance. Whatever, I mean, using the concepts, what has been discussed by Professor Jha, how we can use that for a typical application of predictive maintenance. So what we are doing here is let's, I mean, I won't go into the details of the concept, so that has already been covered. So as we can already understand, the idea is if we can convert data to decision, right? So based on if we can do any of those regression tasks, classification tasks, so any of those prediction tasks which we can do, that is what ideally we want to do. So convert data to decisions. Now what do we want to do? We want to take the condition of the current machine and then predict when the machine will fail, right? So those are the two typical things that we want to figure out from all these things. And now there are multiple terminologies which we are not going to detail. So condition monitoring and predictive maintenance we have heard uh, as well. Now what we do here is, of course, using the data, we will be using machine learning and then take a decision based on that. Now, what we'll do is just what can be a typical application. So there are multiple different applications. One can be in this sort of a thing in manufacturing world. So for example, there are multiple types of nuts being created in a manufacturing floor. And then can we create that algorithm, which essentially what we will have is, if I create an app that will come in the phone, and then if the camera takes an image of the nut, then can we create this algorithm which will tell us which is a good nut and which is a faulty nut. So like the email of spam email or actual good emails, can we do something which will distinguish or differentiate the nut to be a good nut or a faulty nut? So that can be a typical example. The other example which we will talk is the digital twin concept. Now the digital twins, I mean, this particular example is, say for example, we have multiple different pumps from different areas. And now can we actually use all these different sorts of pumps? So based on the from the pumps, can we create this machine learning model? Now say for example, all these things are created from different areas and different there can be multiple different variations in all these pumps right now. So the question becomes like, how do we take care of all these different situations? And now the faults can also be so many different type of faults. Now of course, as also Professor Jha mentioned, is we need to have the data to train these models, right? Without that training part of it, it cannot do all these things. Now what we can do is, say for example, you can also guess, or you can put in the chat window also if you will. Say for example, if we have something like this where we want to create an algorithm which will find out whether the pump is healthy or the pump has some fault. If it has a fault, can it identify which fault it has? It can be blocked inlet, seal leakage, one bearing. We are just taking a particular case here, or a combination of faults. So if we have this this faults, what guess is yours that this is what sort of a problem? Is this a regression model or a classification problem? I mean, uh, the answer is already here. If you have not seen this, it says classification, right? So this is a typical classification problem. Because these are categorical variables. This is a typical case where we have all these faults, and then what we want to do is, if we give this uh, new data to this algorithm, can it identify which fault it has? Um, Now there are multiple different aspects. Like first question comes up, how do we actually create faults? There can be different sorts of faults we can create. We can do a lot of simulation, we can do experiments on faulty machines, we can do multiple different things to generate faulty data. And then the other data which we can have is the sensor data, because that's a real-time machine information that we are having. So these are the two sorts of data which we have, right? The data preparation stage, so sensor data and generated data. By generated data we mean that there can be, if we have to run the faulty scenarios, how can we run those? Do we need to create fault in the machines? Of course that's a possibility, but that of course means it takes more time and money. We can also do simulations and create faulty data. So once we have that data, the next point comes is a pre-processing. So if we have to find out outliers, smooth the data, all those sort of things. Then extraction of features, that's also an important part in these machine learning workflow. Then of course the training model, and of course we have the testing and all those workflows. I'm not going to the details of those. And finally, where do we want to put this algorithm? So we can put this on the cloud, we can put this on the embedded device, and depending on the situation we can decide where to put this algorithm in. It has a lot of things which needs to be taken care of, like how much time it needs to do the simulations and all those things. But these are the situations. So that's where comes things like Internet of Things, where if we have to integrate with cloud, if we have to integrate with enterprise systems, all those communications comes into the picture of how do we actually transfer the data from one place to the other. And then where do we put all those things? We won't cover in detail now because it does, we don't have time. Now, how do we generate faulty data? So here in MathWorks, we have like MATLAB and Simulink. So using Simulink and SimScape, we have generated this data for these pumps with all these different sorts of faults. So here we are just using the components, putting in different types of faults and running the situation. So when we run the model, we basically generate all these different types of data. I won't go again into the details of this fault data generation part because that's a different sort of an part of the spectrum. So how do we create the data? We can run all these simulations and generate the data. Now what we will go into is once we run this, so this is how it looks like inside the simulation environment where we run different sorts of cases and then inject faults like simulation faults where we keep those faults and then run all those different situations. Now what we will focus on for the next 15-20 minutes is once we have this data, what do we do, which is more in line with what the machine learning approach. So I will just load the data. So this is I mean, we will talk about how you can practice on these platforms here as well. So this is MATLAB and I'll just load the data. So we have done all those different sorts of simulations. So this is the pump data and we'll clearly see now how the data looks like. So this is the pump data. So I'm just loading the data, right? So load and then the data file name. So once we do that, we see here that the pump data has come up. Now I'll just go inside and you can see how the data for this particular case looks like. So these are the flow for a pump. So for a pump, right? So we have flow and pressure. So the flow rate and the pressure. And we have different sorts of faults which are categorized by this number. So 0 means one typical type of a fault, 100 means another type of a fault. So all these are number codings for typical faults. Now these are timetables. So if I go inside of this, what we can see is you can see that there is time and data. So this is how the flow rate varies with time. So these are timestamps and this is the data. Data means the flow rate. Now, if I have to just visualize quickly the data, the way we can do this, this is a timetable here. This is a table format in this data structure. So say, for example, if I just want to plot this flow rate, because those are important things. Now, what we have here again in the times of the data is we have inside this timetable, don't worry about the syntax and all those things too much. We will go into detail later on. So this is just for seeing how it looks like. So there are like 240 of these pumps because the pumps are from different areas, different manufacturing plants and all those things. So each of those 240 has these timetables. So for each pump, there is one timetable for flow rate and another timetable for pressure. And similarly, there are 240 such pumps. So if I want to see just the flow rate of the first pump, so I can just say Q1, which is the flow rate of the first pump. And then I say pump data. So this is the data sheet here, pump data. And then pump data dot flow. So that means we are just taking the flow part of it, right? So pump data flow, and I'm taking the first pump. So if I just do this, then let's see what this Q1 is. So this Q1 now becomes this timestamps, right? This has the time and the flow rate. So out of the 240 ones, I'm taking just the first one. So now if I have to, this is again a timetable. So in this timetable, what we have is we have, so if I just go inside of this, you can see here what it looks like. So so you have this time and data, right? So this is the time and this is the data. So data means the flow rate, right? So the flow rate is again this dot data. So if I have to get the flow rate here, so I can say flow rate is equal to Q1 dot data. So the dot means I'm just accessing that particular column. So I have one column called time and one column called data. So dot data means I'm taking the data second column basically, which is the flow rate. So once we have that, I can just plot this. So we say plot of flow rate. And similarly, we can plot both of them, the X and Y axis. This is just for visualization how the data looks like. So this is the typical flow rate data, right? And similarly, we have all these things for 240 such pumps. We have the flow rates and the pressure, right? So we have both these things for 240 of those pumps. And similarly, we can keep on visualizing this, plotting this. So if I want to plot the x-axis for time, what I can do is Q1 dot time, comma q1.data. So what that means is basically the x-axis is the time part of it and the y-axis is the data. So if I do that, you can see that this becomes seconds now, and this is the flow rate. And similarly, you can keep on doing for pressures. Um, Now this is the how the data looks like. So what we will do now is, instead of writing all these lines, there are multiple different applications, apps, where we can do all these things to make things a little easier. Um, so now what we'll do is, inside this apps here, we'll go to one app called a Diagnostic Feature Explorer app. This is typically, so inside MATLAB, there is something called Predictive Maintenance Toolbox, which is for addressing all these different types of applications in predictive maintenance. So inside predictive maintenance, this is this app. The advantages of the apps are basically, instead of writing codes, what we can do is, instead of writing codes, we can use is graphical user interfaces. So here, now what I can do is, I'll just import the data. So I'll import the data that I have loaded, which is basically the pump data. So if I click on next, and basically next, I'm not going to too much detail of this, um, all the syntaxes, which we'll go through later on anyway. This is just an overview of how it looks like. So say, for example, if I take the flow rate and then click on signal trace, you can see that this is, say, creating trace plot for flow data. So signal trace basically means that it will plot the time series data. Um, so this is how the data looks like, plot the flow rate. Now, if we go for ensemble view properties, we can group by fault codes. And then what happens is, all the 6-7 different types of faults are also there, different colors and things. Now, once we have the faults, right, once we have all these data, the important things that comes up is, what are the features here? Now, the features mean basically what sort of characteristics things are there which we can extract, and that can be useful for our analysis. Now, for time series data, there can be mean, standard deviation, mean deviation. All these different sorts of things are features. Similarly, for these data, we can go to something called spectral domain. It's like finding out the frequencies. So all those things are there, which are features. So these are characteristic information from the data. Now, how we can do that? What we can do this is, here, if I go basically for time domain features and say signal features, and then click on OK. So mean, RMS, standard deviation, kurtosis, all these different sorts of features. So if I just click OK now, then for all these 240 data sets, what we will do is, we will find out all those features. Because what happens is, between the healthy data and the faulty data, these are the differences, right? So these features, maybe the mean is different between a faulty data and a healthy data. Maybe the RMS is different between the healthy data and the faulty data. So those are the things which we are finding out from this data set. So that's why from all the data sets, we are trying to find out all the different sorts of features. So these are the features. Now, this is typically the time domain features. Similarly, what we can do is, we can go for spectral estimation and then click on power spectral and then click on OK. So then what we'll do is, it will find out the power spectrum. That means it will go to the frequency domain. So here we have the flow versus time. The x-axis is time. If we go for power spectrum, what will happen is, the power spectrum will be in the y-axis, and in the x-axis we will have the frequencies. So maybe what will happen is, for a faulty data, we will have a different frequency. For a healthy data, we can have a different frequency. So those can be distinguishing features between a healthy data and a faulty data. So that's why we are finding out all this, the information in the features in the power spectral data, in the spectrum, in the spectral domain, which is the frequency domain. And once we have that, what we can do is, we can find out the spectral features. So if we click on spectral features and click on OK, so then it finds out all those different features. And if you see here in this little window here called feature table, it has kind of summed all the different features that it has found out. So there are all these different types of features that it has found out. There is clearance factors, mean. Now it has included the peak frequency as well. So we have all this different bunch of frequencies that it has found out. the features. Now, once it has the found out the features in machine learning, what we struggle is also what are the relevant features? What features do we actually take and what features do we ignore? What are the features that actually make sense? So for that, what we can do is here we are ranking the features. So basically there are multiple different types of statistical tools which can be used to rank those features. Again, we are not going to any detail of those, but here we can click on this ranking features. So here we are just sorting by a technique called one-way ANOVA, and by that what we are doing is ranking the features. And then what we can do is we can see maybe these 3 and this 4, these 7 features probably are more important. So based on this we can decide which feature to include and those sort of things. After that, what we go here is export the features to the workspace. So if I click on export features to the MATLAB workspace, what happens here is all these features get exported to our workspace. So we'll go to the workspace again, and here we will find out once this process has ended. Um, Once this process, so if we click on export, we select the relevant features and click on export, and then we see here that the feature table has come up. Now the feature table is typically where we have those predictors and the response. So here the response is the fault, right? What sort of a fault we have. So if I click here, you can see that these are the predictors. So this is the RMS value, the mean value, the bandwidth, the peak. So these are from the frequency domain, these are from the time domain for all those different data set. And the final column is basically our response, which is the fault code, what sort of faults we have. So this is where we take the data. A simple example where we essentially what we did is we took all the data. Oops. Yeah, once where we took all the sorts of data, and then we created the features. And once we have the features, what we need to do is basically we need to look for the machine learning model, what sort of a machine learning model we can use and these sort of things. So for that, what we will do is we will use another app. So here we are going to the machine learning area, and there is another app called classification learner app. So essentially what we are doing is we are not writing codes, and we are just using the apps because it's kind of easy to use. So here what we'll do is we'll again import the data set which contains the features. So here the feature table is our data set, and we see here automatically this is taken as the predictors, and this is the response. The response means the fault codes, right? What sort of fault is it? The blocked inlet or the leakage or combination of those faults. So all those things are in this area here. Now once we have that, there are multiple different options here which are somewhat details of machine learning where we have to do validation. So basically from the training data set, if we want to keep a little bit of data for validation, and there are multiple things of how to decide on that. Basically we do not want something which will give more error, or so there's errors called overfitting and things like that, which we can kind of reduce by doing this validation techniques. So here we can choose some validation techniques based on the type of data set, and there are like rule of thumb. So if you have like less amount of data, we can go for cross validation. If we have significantly relatively more data, we can go for holdout validation, and so on and so forth. So we click on start session. Now what we have here is uh, inside this, of course, once we load the data, it just shows in terms of just a plot of what do we want to plot here. Now, if we look into here, this contains all the different types of machine learning models for classification. These are all different types of models. We do not need to know what the algorithm means and all those things. We can choose the model we want, and if we do not know what sort of model is good, we can choose all the models. That is also possible. We can choose all linear models, and then there are multiple optimizable things, which is basically how to optimize the algorithm, because the optimization step is basically needed for fine-tuning the model to improve the accuracy. So those sort of things we can do. So maybe I can choose all the models, and then this is for use parallel is basically if I want to use all the cores in my system. So inherently it will use one core, but we can choose 3-4 different types of cores, more number of cores to make things faster. For now, I'm just choosing train instead of choosing the parallelized option. The the initial step takes a little bit of time for parallelization, but then it becomes faster. So you see here the accuracy comes up 51.7, 42. This one gives us 73.8. While this goes on, I can take up this question. So which one to use in terms of platform, Python, MATLAB? Of course, in MathWorks, we are in MATLAB, so we are using MATLAB, but we are doing a lot of things also with Python. So we can use best of both worlds, whichever you are comfortable with. You can use both of them, using the best of both worlds as well, because what we can do is we can, if we have a Python based framework, we can import that in MATLAB as well for the visualization part. So those sort of things also we can do. So maybe you have a framework in Python which we can import in MATLAB, visualize here, or create a code for the hardware, because what we also focus on is, if we have to do for an embedded system, what we can do is we can generate the optimized code for that target hardware. So those sort of things we can do here as well. And then we can go talk vice versa, like something we can build here, we can import to Python, something in Python we can bring it to here, and like that. So those sort of things are also possible. Okay, so by the now we have trained all the algorithms. So tree, quadratic, naive Bayes. So these are all SVM, support vector machines, nearest neighbor, all those different algorithms. And then we see that the accuracy is best where this one is giving relatively better accuracy, quadratic discriminant. And if I go for confusion matrix, though it says confusion, it's pretty easy to understand. So here what we see here is the diagonal terms are basically good ones, where we see the predicted class and the true class are same, right? But these off diagonal times are, the terms are basically not good, where we can improve the accuracy. Now for improving the accuracy, we can go for the optimization algorithm, which basically does change some parameters in the model, and then improve the accuracy. But we do not know whether that is best, but we can try that. There are other things we can see whether we have chosen the right features. We can go back to the feature extraction step and find out whether we need to find out more relevant features. And of course, we can keep on training with more and more data, which will always keep on improving the accuracy. So once we have a model to start with, there are multiple different ways to improve the accuracy, which again, we are not going to the details now. And once we have this, we can just export this model from here. We can generate the code, generate the function, or export just the model as it is. So export the compact model. So click OK. So then what happens is the model gets exported here. This is our model. So now we can use this model for our prediction purposes. So it says here, how do we predict? So say, for example, if I want to predict based on the same data set we have, so we can say trained model dot predict function. So it tells here, how do we want to do this? So it tells here how to call for prediction. So I'm just using that. Now, if you realize here, what we have is the first 5 columns are the predictors and the final one is our response, right? So what we can do is here, what we can say is the feature table. So I'm just giving here feature table, and then what we can do is we can choose only the first 5 columns, and the 6th column will be a prediction purpose, because that's what we want to predict. So this means all the rows, and I'm choosing only the 5 columns, the first 5 columns. And then what happens is, yeah, so here I've made a mistake in terms of the file here. So you can see here, it automatically tells me that the feature table 1 and not feature table. So if I say here, then it gives this column is basically the predicted faults based on the models. So we can see here, this is the same data set we are using, but we can give in all the new data set which contains all these 5 predictors, and then finally it will predict the faults. Right, so this is something what you can do, keep on doing, and then this is just a simple case where we have those PUM data set, and based on the PUM data set, what we are doing here is essentially finding out what sort of faults we have. So that's what we did here. Just to summarize, what we essentially did in this particular case is we got this fault data sets, right? Once we got all these faults data set, we get all those different types of data sets. And one more thing, if you have the data we mentioned, you can get it from different cloud environments, and then different sorts of data stores, all those things to handle more data. So we are not going into, again, the syntax and all those things. Again, important things in terms of domains, a little bit of when we are doing machine learning, we need to know what sort of features we are looking into. Time domain, frequency domain, there can be time frequency domain, and all these sort of things. So these things we have already discussed, so I'm not going to details. yeah, so basically, just to summarize in terms of the flow, what we did. So we have the data, right? So the data stored it can be stored in the cloud, in your hard disk, in the laboratory parallel clusters. So we can have data from the simulation if you have faulty data, and also the data real time we are getting from the hardware. So these two types of data. Processing, data transformation, where we're finding out the features and different sorts of relevant information from the data. Then we are going the ranking the features, which one are the features that we really need, and based on that we are doing the classification operation. So like a typical use case for the classification operation which Professor Jha talked about. So we want to classify the fault. So this is the fault classification. There are other things which we can do more when we go into more details and kind of hands-on examples, where we can find out remaining useful life estimations and so on and so forth. Finally, what we can do is we can put this inside a hardware. We can embed this on side a hardware. It can be like any kind of a hardware, NVIDIA boards, Intel boards, all those different type of boards, or simple Arduino, Raspberry Pi, all these types of hardware. We can generate the code for that, or we can create an app and then use it for our application purposes. So this is kind of the workflows we're following, and just a demonstration of using a simple
Yeah,
pump data
thank
on
you,
that.
Shavik. I think that's a very
Yeah,
nice overview that you have given in such a short time. It's a
good.
wonderful to
Thank you.
get at least feeling means how this can be implemented, because I have just explained the basic concepts, but now we have seen that how it can be implemented. So what I
Right.
will just request you to stop sharing. I will just
Sure.
conclude with the remaining 2-3 slides with me.
Mhm. Yes, thank you, sir.
Yeah, just something is not working with my end. Just a minute. So thanks, Dr. Shavik. I think it's a nice demonstration you have given such a short time. You have explained the intricacies and details of those algorithms and how it can be done. The good thing is that you are not going to write an in-depth piece of the codes for experimenting with any of these algorithms, and that is what not expected also. Uh, so what I would like to now share with you, just a minute. So what's next can be done after this, because you have already seen the code, how it has been implemented. So one I was just going to share, there are good number of Python libraries available for these implementation, as I have asked in the question also, and some of you are familiar with these libraries also. So in fact, this NumPy is already there, the Pandas is there, Matplotlib is there. You are basically using that for, so NumPy is for just dealing with the arrays and matrices. It's more dealing with the mathematics functions, how to operate. So if you are interested in writing the basic piece of the code, you can use that, but basic understanding of NumPy is required, because rest of the algorithms are also using some of the functions there. Pandas is dealing with the data structures, the data analysis. It means how to import even the data from Excel files, CSV data. So that is the one part. Plotlib is just a visualization, because visualization is very important aspect of all machine learning application. You need to visualize the data. You need to understand the data first before you put on any of the algorithm or the function that you want to apply. So visualization, it can be done very well with the Matplotlib. And the core library for this machine learning is the scikit-learn. So this is the library which has all those algorithm here, or the functions available directly to put the classification, regression, clustering, algorithms of SVM, random forest. All these algorithms, as you keep learning and you'll understand the pros and cons of these algorithms, they are available and you can directly call those functions and use it. The Seaborn is again a visualization library based on the Matplotlib, because visualization of the statistical graphics is very important. So that's just a quick overview of the approach. Who want to start learning on Python based libraries, I think a lot of resources are available for them. Now, what I want to share with you toward the end of this course, those who are still in the webinar, and then what would be the next step. So we have already designed a good plan for you. Those who have understood the very basic things from this webinar today and are interested to take the next learning with us, we have already designed a program for you. But before that, you have to finish a basic learning on MATLAB, because what Shavik has explained to you is the same platform we will be going for further learning and implementing these algorithms. So there are two courses basically available on MATLAB on MathWorks website. which are free, and each of these courses are 2 hours course actually. So you can do a basic hands-on on MATLAB on-ramp, and then there is a machine learning on-ramp. So these are the 2 basic courses. Once you are able to do that, we have a very good program and a workshop aligned for you. That is a hands-on machine learning workshop. The way we have done a webinar today, we will be having a more interactive session, and we will allow you to do all those experiments which Shavik has done today. And this workshop is aligned on 19th October 3 to 5:30. So those who are really interested to do hands-on learning on machine learning applications, the basic models, how to apply, how to test them, I think this is one of the workshop which will give you enough learning in that case. But there are very limited seats to this workshop because it requires MathWork licenses also, which will be made available only to those who are participating in this workshop. But in that case, we want that you have to finish both these courses before you register for this workshop, and that is must. Without going through these 2 basic courses, there's no point in sitting in the workshop. So idea is that you please finish these 2 courses. This will take only 4 hours of your time. So today is 14th. We are planning this for the 19th. You have 4 days times in time in between. Please finish these 2 courses because we require certificates of completion of these 2 courses to register for this workshop. So that will be the prerequisite. All those who have attended today's workshop, we will send the invitation for this and even the registration link for the machine learning workshop to be held on 19th October. But to participate in this workshop, you have to finish both these courses, and you have to attach basically or submit the certificate of completion, because this workshop is certainly take you to a deeper level of understanding and learning, and these 2 courses are just a prerequisite to that. I think that is all from my side for today, and thanks for your kind attention. Some of the questions I have already responded on the Q&A. So let me see if there's any other question for me. I can just take them up. So I think there are many questions related to the website access and then recording. So what we will do once this machine learning course is uploaded on the website, we will share you the code to register for the or enroll for the course. What you can do with the today's details, you can register for at least the basic courses over on the website. So that is the overview of smart manufacturing and IoT courses. And with the data that we have received from today's webinar, we will share you once the machine learning course is available on that. And the recording of all this complete session will be available there. Yes, I think if you have done a MATLAB course on Coursera, if you can attach a certificate of that, we will give you a seat in the workshop. That's a question over here. Recording of the machine learning workshop will certainly be made available, but idea is that the hands-on workshops are normally done in a more interactive way. So if you are really interested, these 2 courses will not take much time of you, and you can finish that learning and can join the workshop. We will provide the recorded videos of the workshop also, but idea is to have more interactive workshops so that any doubt, any problem you are facing while you are implementing any algorithm, that can be addressed immediately. So I think hands-on learning means just a laptop or a desktop is required for this workshop. There is nothing required as such, because MATLAB and Python both can be made run on any of the PC. No, if you have not have any certificate on MATLAB and then certainly you can go with this on-ramp course. It is easy because if you know MATLAB, you can finish it much faster. So just do it so that it will brush up your fundamentals and make you more ready for the workshop. So I will send you the link to upload, because once you finish it, you get a PDF of the certificate, and then we'll provide the registration link to upload that certificate in the same link. So I think these are some of the quick questions that I have. Anupji, I am done. Any last remark from you? I think then we can close the session.
No, I think it's a beautiful session, and Souvik, thank you so much for participating today. We hope to have many more programs.
Sure.
I think just the codes, if you can flash once again or on the chat box or something,
Okay.
for people to be very, very sure how they can participate in the previous programs.
Yeah, just a minute. Just do that. So I'm just sharing the codes, those who are interested and want to note it down for the registration and enrollment on the previous courses. So these are the two courses which was mentioned, and these are the two codes. So you will be specifically enrolled in this particular course only. So with this code, you will be enrolling yourself into one course only. Same code cannot be applicable to all the courses. So those who don't have much experience with MATLAB, but what I will suggest, if they can just go with this basic 2-hour learning, that would be good enough to take the next step with us on machine learning with MATLAB. Octave, learning on Octave will certainly be helpful, but because we will be doing this workshop on MATLAB, so a quick hands-on is also required on MATLAB. Fine. I think if there are no more questions, thank you so much for your attendance till the end and then patient listening on this subject. I will be just closing the session now. Any other query you can post quickly on this, you can address. Otherwise, the webinar is over.
Yeah, the chat window will be available for the next 2-3 minutes, I guess.
Yes,
While
yes,
the
yes.